Okay, now we're recording. Okay, so today we're going to do the electrolysis of water. And Joshua already told us that electrolysis is breaking down water using electricity. So our objective is going to be to break down water. And we asked, well, what is water? What are we going to get when we break it down? So then Max told us water is 1 oxygen and 2 hydrogens. So what holds them together? What did you say?
Chemical bonds.
Chemical bonds. So we have an oxygen atom, 1 oxygen atom. We have 2 hydrogen atoms, and they're held together with these little sticks. These little sticks represent chemical bonds in that drawing. Does anyone know what a chemical bond actually is? Joshua?
Electrons.
Okay, so a chemical bond, this little stick, represents the sharing of electrons between this oxygen and this hydrogen that are connected with it. The chemical bond is the sharing of electrons. Okay, so our goal is to break down water. If we break down a water molecule, what do you think we'll get?
What do you mean, like you're going to have 2 hydrogen and 1 oxygen, or what do you mean?
Yeah, that's exactly what I mean. So you think when we break down water, we can write its chemical formula here, H2O, 2 hydrogens, 1 oxygen. If we break it down, we're going to get hydrogen atoms and oxygen atoms, right? And this proof is a little bit different than that. Hydrogen and oxygen don't actually exist in nature as hydrogen atoms and oxygen atoms. They can't stand to be by themselves because of the way their electrons are arranged. And I'll teach you that later in chemistry. But hydrogen atoms always pair together as a hydrogen molecule. So like an H chemically bonded to an H. And oxygen atoms always pair together as an oxygen molecule. And O, technically, is double bonded to another O. But that's kind of complicated. That's what actually happens, though. So when we take water and we break it down into its elements, we produce hydrogen and oxygen. Now, what state of matter is water in? Is it a solid, a liquid, a gas? Liquid. Liquid at room temperature. So we've got some liquid water. And how about hydrogen and oxygen here at room temperature?
Gas.
Gas. So we're going to expect to make our liquid water turn into 2 gases when we run electricity through it. The energy will break it down. So if our objective is to break down water, well, into what are we going to break it down?
To a gas. Breaking water into a gas.
Okay, so the 2 gases that make it up, and they are... Oh, actually, I want to go somewhere else with this. To break down water. So we talked a lot about what is water. It's 2 hydrogens bonded to an oxygen. Is it an element? Is it a compound? What is it, Chris?
A molecule.
It's a molecule. And since it's a molecule, it's not an element, it's a compound. So we're going to break down water, which is a compound. A compound is something that has a chemical formula, like H2O. It's something that has atoms chemically bonded to each other. And we're going to break water down into, and Lily, you told us that, we're breaking the compound water down into
A gas.
these 2 gases. And those 2 gases are, do you know, anyone know?
Hydrogen and oxygen.
Hydrogen and oxygen, and they're elements. Hydrogen gas and oxygen gas, which are elements. They're they're really confusing elements, though, because they exist as these molecules instead of existing like normal elements as atoms. But they're elements. So we're going to break down water into elements. Would you think that water will have the same properties as the hydrogen and oxygen that make it up? No. We learned in like module 1 or something that when you have a compound made of different elements, it has different properties than the elements that make it up. Once those elements chemically bond to each other, their properties change. They become that of water instead of hydrogen or oxygen. For example, you can see that these will be gases, that will be a liquid. So a key point here is we need to start our experiment because it has to run a long time and then talk. Max?
This is Matthias.
Yes.
If we're breaking down water, which is the 2 hydrogen atoms and 1 oxygen, why would we get 2 oxygen atoms?
You're exactly right. We haven't gotten there yet. The back of your lab sheet has that question on it, so we'll have to hold off for a minute. But we're going to get there, don't worry. That's an excellent point. So hold tight. So the hypothesis says, what is the chemical formula for water? So what should you write there?
Oh, H2O.
H2O. What is the chemical formula for water? Well, that's H2O. Then it says, when water molecules are split into atoms, which one do you think you'll make more of? And this kind of starts going to where Max was thinking. So, do you think you'll make more hydrogen gas or more oxygen gas when you split
Hydrogen
water?
gas.
Why?
Because there are 2 hydrogens in the water molecule.
Right. So you have 2 hydrogens in a water molecule for every 1 oxygen. Twice as many hydrogens as oxygen. It's hard to tell that's not a 10. And gas behaves in such a way that even though hydrogen is a tiny atom and oxygen is a much bigger atom, the same amount of gas takes up the same amount of space, regardless of the size of the atom. So we can literally just compare amounts and say, we made twice as much hydrogen gas as we did oxygen gas. And when we just eyeball and compare amounts, we can actually see that we're going to produce more hydrogen gas than oxygen gas. So our paper here, maybe you want to circle which one you think is going to make more, the hydrogen gas or the oxygen gas. I'd go for hydrogen because there's 2 hydrogen atoms in water for every 1 oxygen atom. So when water molecules are split, will there be more hydrogen gas or oxygen gas? Or the same amount of each. So you can make your hypothesis there based on what you think from H2O, which one will you make more of. Then you're going to have a battery to provide the electricity for the electrolysis of water. And a battery, of course, has a positive terminal and a negative terminal. The battery's negative terminal produces the hydrogen gas, so fill in the H2 in that question. The battery's negative terminal produces hydrogen gas. The positive terminal produces oxygen gas. And then everybody will, we're going to pause and set up our